What is the reciprocal cosine? What's 1 over sine? What's 1 over tangent? What's 1 over cotangent? 1 over secant. And 1 over cosecant. Alright, so is everybody confident they know their reciprocals? Okay, the other thing that comes up frequently that you really need to know is how to write sine or tangent and cotangent in terms of sine and cosine. What is tangent? What is cotangent? Okay, because they're reciprocals, so it's just flipped. All right, any questions there? Okay, so then Friday we did the review. The first 4, the directions said to write it in terms of sine and cosine, but if you recognize an identity off the bat, you could do that first. And then simplify. And then the next ones were proofs. So given that we have a quiz today, I haven't been having you grade your own proofs because there's multiple ways of doing it, but take a look at this and see if there's anything you want to talk about. The first 4 I could tell you the answer on those. Number 1 should turn into secant theta. Number 2 turns into cotangent x plus sine x. Number 3 is cosine squared x. And number 4 is 1. Are there any of those 4 that you would like me to look at? No. Okay. So strategies for proofs. You have to box in a side so we know where we're going to. You guys are getting better, but a few of you, your work is still really hard to grade. So it helps me a lot if I know which side you're starting with. So please, please box in a side. I'm assuming pretty much everybody boxed in tangent. Okay. No obvious identities here. What I look for first is, do I have a Pythagorean identity? You know, if I see a 1 plus tangent squared x, I don't usually change that into sines and cosines. If you see 1 plus tangent squared, what are you going to put that as? Secant squared. So you look for those obvious identities, especially the Pythagorean ones. But nothing squared here, so we can't do any of those. So I'd say sine and cosine is about our best option. Cotangent is cosine divided by sine. Okay, we have a fraction and a fraction. So think about all of our strategies. If you are adding or subtracting fractions, what do you have to get? Common denominator. If we are dividing by a fraction, we have to flip and multiply, right? Before I could flip and multiply, I would have to get a common denominator down here. And you can do that. But we also did talk about strategies to make life a little bit easier. What else could I do instead of just getting a common denominator? Yeah, I just have a sign in the denominator. Could I just say, you know what, I think I'm going to multiply by sine A on the top and bottom. Okay, in a fraction, as long as you do it on both numerator and denominator, that would be a legal move. And it just saves me the step of having to get common denominator first. So we'll get to the same point, it's just a little bit faster. If I distribute, I don't think I'm going to multiply it out on top, just because I'm hoping to get a tangent, which I know is sine divided by cosine, so I'm hoping something cancels out. And if we need things to be canceled, they have to be factored. On the bottom, though, I really don't have a choice because I'm getting rid of that fraction. So this would be sine A cosine A. Plus, when I multiply these two, what happens to those signs? All right. It's not overly pretty yet, but we are very close. The denominator has 2 terms. What do both of those terms have in it? So you can factor that out. when you factor it out, it's like dividing. Okay, so in this one, when I divide it out, it just leaves me with a sine A. In this one, if I divide by cosine, what's cosine divided by cosine? So now what happens? So I have sine A over cosine A, which is tangent A. Okay, so not the only way to do it, but multiplying. When you have a fraction and a fraction, if you want to just multiply by the denominator, that does help. What else? You guys are okay on like problem 7, getting a common denominator and adding those?